Okay, so in this problem, you want to solve this linear inequality. So we have this inequality here. This is not an equation, it is an inequality. But for the most part, solving an linear inequality like this is very similar to solving a linear equation. So notice with just as with an equation, you would use a distributive property to get rid of these parentheses. Because notice that every term that's inside this parentheses, this expression x minus 2, is being multiplied by 3. So you're still going to use the distributive property. The same thing here. You're going to multiply all of these terms by positive 2. And when we do that, we get 3 times x is 3x, 3 times a negative 2 is a negative 6, 2 times 3x is 6x, and then 2 times 2 is 4. And that's greater than 3x minus 5. So when I simplify the left-hand side, I use a distributive property, and now I see that I have these 4 terms. These terms, some of these terms can be combined. For example, 3x and 6x, those are like terms because they have the variable x raised to the same power. They're both being raised to the first power. So when I add 3x and 6x, I get 9x. I get 9x here. Then my constants, a negative 6, remember that's a negative 6, not a 6, but a negative 6, and a positive 4 is a negative 2. And that's going to be greater than 3x minus 5. All right, so at this point, I made this inequality much easier to deal with. So I have this right here equivalent to each of these, meaning that the solution that I end up with will be a solution for each of these statements, for these inequalities. Now, when solving a linear inequality, just like you would with solving a linear equation, you want to bring all the variables to one side, constants to the other. And normally with an inequality, usually what students will do with an inequality is they'll first of all, if you have variable terms on both sides, they'll first of all determine which side the coefficient is the largest. So notice that this coefficient is a positive 9, this coefficient is 3. So since this term has a larger coefficient, we're going to bring this 3x to the left-hand side to keep the coefficient positive. That's the main reason. It did not matter, though. You could have brought the 9x to the other side if you wanted to. It did not matter. But I'm going to go ahead and bring the 3x to the other side. So remember, in order to do that, you got to think of its opposite. So right now, this is a positive 3x. In order to get that to be a 0, I need to subtract 3x. And it makes sense because 3x minus 3x is 0. But remember, what you do to one side, you have to do to the other. And then combine like terms, just like you would with a linear equation, or any equation for that matter. You have 9x minus 3x is 6x, minus 2 is greater than, and 0, and a negative 5 is a negative 5. And then to solve for the variable x, we're going to isolate this term 6x, meaning I want to get rid of the subtraction of 2. So the opposite of subtracting 2 is to add 2 to both sides. What you do to one side, you do to the other. Notice I'm aligning my terms. When I combine like terms, this is 0, so I get 6x is greater than a negative 5 and a positive 2 is a negative 3. And then I'm going to just go ahead and rewrite this over for right now. And then remember, you're trying to solve for x. So right now I'm multiplying x by 6. The opposite of multiplication is division. So I'm going to divide both sides by the coefficient of x, which is 6. Don't divide by 6x, divide only by the coefficient. And then simplifying, 6 divided by 6 is 1. 1 times x is greater than, and then if I reduce this, negative 3, 6, I get a negative 1/2. So there's your solution. So the solution to this linear inequality is any real number that's greater than negative 1/2. So that's an infinite number of solutions. If this was in an equation, all these would be equal signs, which would mean that there's only one solution. But that's an inequality. So in this case, you have an infinite number of solutions. So if you were to graph this on the number line, is let's say zero's here, negative 1/2 is to the left of 0. And since this is strictly greater than, there's no equal sign. See, there's no equal sign here. Strictly greater than. There's no greater than or equal to. It's just greater than. We're going to put an open circle. If this was greater than or equal to, remember you put a closed circle. But since that's just greater than, you want to shade in every real number that's greater than negative 1/2. That's what that says. So you're going to shade in like this, like I'm doing, with an arrow. So what you've shaded in was the solutions. Now you want to write the solution in interval notation. So interval notation means you're going to go from left to right. You're going left to right. You're going to write your solution in interval notation going from left to right, meaning going from smallest to largest. So I'm going to start with this open circle, negative 1/2. But remember, when using interval notation, you're going to use parentheses and or brackets. Since this is an open circle, you're going to say parentheses, negative 1/2, comma, all the way, and this just keeps on going all the way to positive infinity. So like 1,000, 100 million, 2 billion, 3 trillion, and so on. So it's just getting bigger and bigger and bigger. So we use infinity. Now remember, whenever you use infinity, negative infinity, regardless of whether this is closed or not, you're always going to use parentheses. So this right here is your interval notation right here. Your interval notation. All right. So that is number one. So that's one way of doing number one, which we saw in this case was we brought all the variables to one side. Now I want to do this because some of you may have done this. So at this point, remember this point right here where we had, actually was this, where we had 9x minus 2 is greater than 3x minus 5. Remember the way I did this was I brought the variable terms to the left. What I was saying earlier, just like with an equation, it did not matter whether you brought the variable terms to the left or the right. It does not matter. This time, let's go ahead and bring them to the right, just to show you what you would need to do. So I'm going to subtract 9x from both sides. Then notice I'm aligning my like terms. When I combine my like terms, this is 0 right here. 9x minus 9x is 0. 0 and a negative 2 is a negative 2. Is greater than 3x minus 9x is a negative 6x. Notice a negative 6x minus 5. Then to get that negative 6x by itself, right now I'm subtracting 5. The opposite of subtracting 5 is to add 5. I'm going to do that to both sides. Combining like terms, negative 2 plus 5 is 3. So I get 3 is greater than, and then negative 5 plus 5 is 0 here. So negative 6x and 0 is a negative 6x. So that's where I'm at. Okay, now remember, at that point where we had this, we had to get x by itself. So that's where we divided both sides by the coefficient of x. Same thing here. You get x by itself. Let me go ahead and rewrite this. So to get x by itself, I'm going to have to divide both sides by the coefficient of x, which is a negative 6. But remember, we have an issue here. Whenever you divide both sides of an inequality by a negative number, you must reverse the inequality symbol. And some students forget to do that. So in other words, this right here is no longer greater than. It should now be less than. And so we get 3 divided by negative 6 is a negative 1/2 is less than, and then negative 6 divided by negative 6 is 1. 1 times x is x. So when you read it from left to right, this reads negative 1/2 is less than x. Okay? Now remember what this means right here. Negative 1/2 is less than x. Many students get confused with this because with inequalities, they're so used to the variable x being on the left-hand side. See, in this case, this was so much easier to be able to graph and to write as an interval notation because the variable x was on the left when dealing with an inequality. It was on the left. Here, it's not on the left, it's on the right. So what this means is that negative 1/2 is going to be smaller than any of the solutions. That's what this means. Negative 1/2 is going to be smaller than any real number that's a solution to this inequality, the original inequality. Which means this, by the way. So here's negative 1/2. And since there's no equal sign, you could put an open circle. And remember, this means negative 1/2 is the smallest of any of these of the solutions to this inequality. So that means this: negative 1/2 is the smallest, which means that all the solutions have to be bigger than this. That's what you see here. So if you write it backwards, going backwards, this says x is greater than negative 1/2. All right. So this one, and remember earlier I said many students, when dealing with linear inequality, they want to get the inequality in such a way that the coefficient of x is positive. And that's what we did here. So to get the coefficient of x positive, we brought, since positive 9 was greater than a positive 3, we brought the 3x to the other side. It did not matter, just like I mentioned, whether you bring them to left or right. You just have to remember, though, that whenever you divide both sides of an inequality by a negative number, you have to reverse the inequality symbol. And then that could bring issue to your thinking, because with inequalities, for some students, it's hard to imagine the solution, what the solution is, what this means when the variable x is not on the left-hand side. But all you got to do is just rewrite it backwards to where you get x to be on the left-hand side. All right, so that was number 1. Okay, now let's look at number 2. So number 2, we have a compound inequality. We have this: negative 4 is less than 2x minus 5 is less than or equal to 7. So we have this linear compound inequality. And it's compound because you have more than one inequality symbol. So you have 2 of them. Now, when it looks like this, where the variable expression is in the middle and it's bounded by 2 real numbers, see 7, negative 4, those are constants. When it's bounded by constants, 2 real numbers, the best way to do this is to think of it this way. So let's suppose it was just this problem here. So I'm just covering this part up. For this, what would you do? You to get x by itself, you would add 5 to both sides, right? Well, same thing here, but except there are 3 parts. So you add 5 to the middle part, you add 5 to the right-hand side, and you're going to add 5 to the left-hand side. And then combining like terms, I then get negative 4 plus 5 is 1 is less than, this is 0, so you get 2x, and that's going to be less than or equal to, and then 7 plus 5 is, what's that, 12? Okay, so that's what I get. Now if I go further, still covering this part up, the next step, remember, is to get x by itself. Right now I'm multiplying x by 2. The opposite of multiplying by 2 is to divide by 2. But remember, though, there are actually 3 parts, so you have to do this as well. So divide all parts by 2. And so therefore, when I simplify, I get 1/2 is less than, this becomes 1 times x is x, is less than or equal to 6. And you found your solutions. So my solutions to this original compound inequality is going to be any real number that's between 1/2 and 6, and including 6 because of that equal sign. So how does this look on the number line? Well, this is what it looks like. Here's 1/2, here's 6. Since there's no equal sign here, I'm going to use an open circle on 1/2. Since my solution can be 6 because of the equal sign, I'm going to put a closed circle on 6, just like that. And you're going to shade in every number, every real number between 1/2 and 6. Notice there's no, notice there's no arrows here because I'm being bounded by 2 real numbers. So it's not going to infinity, it's not going to negative infinity. Your solutions are only between 1/2 and 6. It's still an infinite number of solutions because all these rational and irrational numbers in here are solutions, and there are an infinite number of those. In interval notation, you go from left to right. So that part's going to be easy. Always look at the graph if you need to, or even the inequality solution right here. In interval notation, you're just going to say this. You're going to say, since there's no equal sign, parentheses 1/2, comma, all the way to 6 with a bracket. Bracket because of that equal sign. So parentheses and open circle correspond. Bracket and closed circle correspond. All right, so that was number 2, the easy way to do number 2. I find, though, and I'm going to rewrite this over, that some students, even though this is the more efficient way, some students want to rewrite this compound statement as an AND statement, which is fine. They can do that. Just be aware, though, it's a lot more work. And at some point, you're going to have to understand how to solve AND statements. And there are such a thing as an OR statement. You're going to see that when you're looking at absolute value inequalities. But right here, let's go ahead and rewrite this statement as an AND statement. So that's just another approach that some students will use instead of using this. Although you can see this is so much easier, so much more efficient. It is a lot quicker to get the solution. Okay, now if you're going to write this as an AND statement, here's what you have to do now. You're going to first of all cover the right-hand side, and you're going to say -4 is less than 2x minus 5, and you must say and. That is an AND statement. Whenever you write two compound statements, you must either have the word and or or. And means something totally different than or. And means intersection. Or means union, U-N-I-O-N. But this is an and statement, so that's going to be an intersection. And at the same time, you're going to cover this part up right here, and you're going to say 2x minus 5 is going to be less than or equal to 7. So again, notice what I did. I covered this and just rewrote what I saw. And at the same time, 2x minus 5 has to be less than 7, less than or equal to 7. That's what this says. -4 is less than 2x minus 5, and at the same time, -2x minus 5 has to be less than or equal to 7. All right, and then what you're going to do now is you're going to solve each of those individual inequalities. So I got to get x by itself, so I'm going to add 5 to both sides. -4 plus 5 is 1. 1 is less than 2x. And notice this right here is this right here. See that? 1 is less than 2x. Then you can divide both sides by 2, and so I get 1/2 is less than x. Okay, now remember, this right here, 1/2 is less than x, is the solution to this linear inequality. That doesn't mean it's a solution to the original. Okay, you got to be careful. What you just found is the solution to this. Now remember, as I said earlier, many students have trouble when the variable x is not on the left. So just go ahead and rewrite this. So 1/2 is less than x means that x is greater than 1/2. That's what that means. Okay, and remember, that is the solution to only this. Let's do this one now. We're going to add 5 to both sides also. And when I do that and combine like terms, this is 0. I get 2x is less than or equal to 12. Getting x by itself, you can divide both sides by 2 and simplify. I get x is less than or equal to 6. Now x is less than or equal to 6 is the solution to this only. Okay? Now, once I get to that point, I want to find the solution to the original compound inequality. That's where the and comes in. That's where that intersection comes in. And here's what you have to do. Think about this on the number line first. Let's graph this. X is greater than 1/2. So here's 1/2. Greater than is going to be an open circle going to the right. Let's do this one now. X is less than or equal to 6. Here's 6 on the number line. Make sure you put 6 in the right place in comparison to 1/2. So 6 is to the right of 1/2. That's an equal sign, so we're going to put a closed circle. And then I want all the solutions that are less than that. So you can go to the left like this. But remember, this is an and statement. So the solution to this compound inequality will be the intersection of these two right here. So the intersection of these two. So this is where the two graphs overlap, the two sets of solutions overlap. And so they overlap from 1/2 to 6 with a closed circle and an open circle. And notice this right here is what you see here. And so therefore in interval notation, you're going to say parentheses 1/2, comma, 6 with a bracket. All right, so notice there are two ways to have done this. The most efficient way to solve a compound inequality that looks like this is to get x in the middle. Some students always seem to want to rewrite this statement as two inequalities. Just make sure you put the word and. If you don't, you're not going to get full credit. Then you're going to solve each one individually, and then you're going to find out where those two sets of solutions intersect or overlap, and then that will be your solution. All right, so that is it. So that is solving a linear inequality and then solving a compound inequality.